Okay, here's what we got for chapter 6. We're going to start with the expected value and standard deviation. So it's all kind of predicated on using the probability distribution table. So what we're going to do is go ahead and share that screen, take a look at the question. First question says, find the expected value and standard deviation of each random variable. So we're going to start with letter A and kind of walk through the process. So the way we figure that out is, kind of copied it over here. I'm trying to find the expected value and the standard deviation of this. So the expected value is the mean. So what you're going to hear is you're going to hear the following. You're going to hear it called E of X, which is expected value. You're going to see it called mu of X, which is expected value. You're going to even see it like written out in the words expected value. But in all the cases, what it is, it's the sum of each individual outcome and its corresponding probability. So what it really is in its simplest form is we take the first outcome, which is 10, multiply it times 30%, take the second outcome 20, multiply it times 50%, take the third outcome 30, multiply it times 20%, add them all together. So what it's going to come out to be is going to come out to be 19. So I mean it's 3 plus 10 plus 6. That's what that is. Now, I will show you this is the way you're going to do it on the calculator. In the calculator, you're going to go to your calculator, and you're going to go ahead and you're going to do second plus 7, 1, 2 to clear the memory of your calculator. Now what I'm going to do is I'm going to go ahead and hit the stat button. I'm going to pick number 1, which is edit. Number 1, which is edit. And then what I'm going to do is I'm going to put all of my outcomes in L1. So my outcomes are 10, 20, and 30. I'm putting all those in L1. In L2, I'm going to put their corresponding probabilities. So in this case, I'm going to put in that 30%. 30% of the time it's 10, 50% of the time it's 20, 20% of the time it's 30. And now what I want to do is I want to actually multiply every one of these outcomes times its probability. So the way I do that is over here. I go to L3. I'm going to arrow up to the header row. And I'm going to kind of go down here so you can see what I'm going to do. I'm going to hit the second button here. Then I'm going to hit the number 1 button. And if you look above that, that gives me L1 times second 2. And what I want to show, what it puts in the calculator is, it's putting in the expression L1 times L2. So when I hit enter there, it's going to give me that 3, 10, and 6 I had. So now what I want to do is I want to add those numbers together. I know you can just add them together looking at the row, but I want to show you how you can do that in your calculator. Second, mode to quit. And then what I'm going to do is I want to add up those 3 columns. So the way that I do that is this. I hit the second button. I hit the 0 button to get to the catalog. And if you look at the catalog, it puts me at the A's. I'm going to hit number 4, which puts me to the T's. But I'm going to arrow up twice. Once, twice. And when I arrow up twice, I get sum. I hit enter. And I want to sum up L3. So I do second 3, enter. And that's where it gave me the 19. So I did this by hand here, but what I'm telling you is in the calculator, you can use that L1, L2, L3 thing. When you're writing down, let me show you what work is. I would want to write this down as work. E of X equals the first term, 10 times 0.3 plus ... The last term, 30 times 0.2 equals 19. So you don't have to put any middle terms as long as you do the first and the last. So that's the mean. That is the average. That is the most likely outcome of this. So if you look at this distribution, the mean of this, so the mu of X is 19. Now, as you notice, that 19 is not an outcome, and that's usually going to be the case when you do this. When you do this, you're usually going to end up with a mean that's not one of your outcomes, and that's fine. That happens. So that's our mean, and usually the thing that goes together with mean is standard deviation. Now, here's the deal with standard deviation. There's a little bit of extra work we're going to have to do, but we're still going to do it in the calculator. The first thing I need to realize is to get standard deviation in statistics, I have to go through this thing called the variance. And that's what's called the variance. And the variance is merely the standard deviation squared, because standard deviation is sigma x, sigma squared x is variance. So what I'm going to do is I need to figure out the variance first. And here's the formula for variance. It is the sum of the difference between each one of our outcomes. So in this case, our first outcome is 10 and 19. So the difference there squared. We make it squared because we want to make it positive so that when we sum everything up, we don't offset negatives and positives. We're going to multiply that times its out by its probability of 30% plus 20 minus 19 squared times 0.5 plus 30 minus 19 squared times 0.2. That's going to give us our variance. That's not going to give us our standard deviation. What we do then is we take the square root of our variance. We take the square root of sigma of x squared. So the square root of this guy up top, and that's going to give us our standard deviation, the expression above. Now, again, that's a lot of work in terms of math, so I'm going to show you how we do that in the calculator. The way we do that in the calculator is we go back to our edit, stat edit. Now what we're going to do is we're going to arrow over to the L4. We're going to go up to the top. And what I want to show you is, let me get this all done at once. What I want to show you is what we put into the calculator. We're going to put in a formula. We're going to do open parentheses. We're going to do second 1 to get L1 minus, we're going to hard code in what that mean was, which was that expected value of 19 squared times second 2. So we're going to do the difference between our outcome and the mean of 19 squared times L2. That's going to give us 24.3, 0.5, and 24.2. We want to go back, we want to add that up. So a good way to do that is if I arrow up to this sum L3 and I hit enter, it copies it down. And then I want to overwrite it with L4. And that tells me that my variance is 49. What it tells me is that this expression right here equals 49. So what it tells me is that my variance is equal to 49. Therefore, my standard deviation is equal to the square root of 49, which is 7. So what I want to show you is what counts as work. So what counts as work is this. The standard deviation is equal to the first term, 10 minus 19 squared times 0.3 plus ... plus the last term, 30 minus 19 squared times 0.2. And then we're going to put a big old radical over top. And when we do that, we end up with standard deviation of 7. So what that tells me is that this distribution has an expected value, has a mean of 19, and a standard deviation of 7. So now what I'm allowed to do is I can get to a quick answer on a question. I don't have to go working through the whole thing. So this is how we do standard deviation. This is how we do mean using the calculator. So we did some extra practice in class, but this is just the example we worked through. So now, let's talk about some potential questions and the way they may be worded in a question. So let's go ahead and say that I had the following. I'm going to look at this question 3. A couple plans to have children until they get a girl, but they agree that they will not have more than 3 children, even if all are boys. Assume boys and girls are equally likely. So in this case, if we look at this, we didn't get a distribution model. So what we need to do is we need to make a distribution model. So this is a family that's going to have 3 kids. So if you think about it, what's going to happen is I'll make a tree diagram. They're going to have a family, and what they're going to start off with is they're going to have either a boy or they're going to have a girl. And if each are equally likely, we're going to put 0.5 on both. Now, the thing to remember is they are going to stop as soon as they have a girl. They want to get a girl. So what's going to happen is they would stop right there. They'd be done. So now we got to look at the other branches of the tree and see what happens. So again, they're going to have a second child. It's either going to be a boy or it's going to be a girl. So in this case, again, 50-50 chance. But the way you want to think about it, they're going to stop if they're right there. And now what's going to happen is they're going to try for a third time. And when they try for that third time, they're either going to have a boy or they're going to have a girl. So in this case, again, don't want to change colors yet. 50-50 chance that they have a boy or a girl. But in this case, yes, they're going to stop here because they have their girl. However, what's going to happen here is they are going to go ahead and they're going to stop as well here because they said they're not going to have any more than 3 children. So now those are the 4 outcomes. So if you kind of think about it, what are the sizes or what are the number of girls? In other words, what are the number of girls you would expect to have in the family or the number of children you would expect to have? So in this case, if we're looking at the number of children that they would have either 1 child, that's these people, they would have 2 children, or they would have 3 children. And what are those probabilities? So those are my outcomes. Here's my probabilities. So the probability that they'd have just 1 child, that would be if they just had a girl, is 50%. The probability that they had 2 children is going to be only if they had a boy and then a girl. So that's 0.5 times 0.5, which is going to give me 0.25. 0.25. And now you can actually use the rules of a distribution table to figure out the last one, because we know that this has to add up to 1. 50 plus 25 is 75, so we know this has to be 25. But here's the thing, let's think about that. They could have had a family where there was all boys, so that's 0.5 to the 3rd power, and 0.5 to the 3rd power is 0.125, or they could have boy, boy, girl, which is also 0.5 to the 3rd power, which is 0.125. And so we're going left to right on branches, multiply, up and down, add. That's how we got that. So again, what is the expected number of children they'd have in this family? The way we do that is the expected value would be 1 times 0.5 plus 2 times 0.25 plus 3 times 0.25. So realistically, it's going to be 0.5 plus 0.5 plus 0.75. So we'd expect this family to have 1 and 3/4 children on average. So these families would be about 1 3/4. Again, I know it doesn't make sense in the context of you can't have 3/4 of a child, but in the context of this problem, we would say that 1 3/4 children. And to figure out the standard deviation, we're going to go ahead and take the square root of the variance. So in this case, it's going to be 1 minus 1.75 squared times 0.5 plus 2 minus 1.75 squared times 0.25 plus 3 minus 1.75 squared times 0.25. And we go to our calculator. You can use the L1, L2, L3, but in a case like this, I would probably just do the math this way. So again, it's 1 minus 1.75 squared times 0.5 plus 2 minus 1.75 squared times 0.25 plus 3 minus 1.75 squared times 0.25. And that's our variance. And a quick way to get to the standard deviation is we take the square root of that. So we do square root, or we hit the caret key, answer to the 0.5. It's about 0.8291. So what that tells me is our standard deviation is 0.8291 children. So you would expect this family would have about 1 3/4 children with a standard deviation of about 0.8291. So, again, the way I always kind of look at this is just adding and subtracting 1 standard deviation. The range of this family is going to be 1, which is basically what this is. So if we subtract 1 to about 3, and that's really what it is. I mean, families are going to be 1 to 3. So that's what we deal with expected value. So again, this is how you do standard deviation and mean in your calculator. This is how you would answer a question in a probability distribution. The next video is going to talk about how we can actually like combine distributions.